So let's take a look at problem 1, identifying congruence transformations. In the figure at the right, triangle PQR is congruent, that symbol means congruent, to triangle STU. What is a congruence transformation that maps triangle PQR to triangle STU? So we are trying to go from this triangle PQR, we're going to try something with it to get it so that it lies exactly on top of STU. Now something important I want to point out to you is, let's make a note. We know that P is going to go to S. So vertice P is going to go to vertice S. Vertice Q is going to get mapped to vertice T. Vertice R is going to get mapped to vertice U. Order is important in these things. We're going to see some examples of that in our homework. So now that we know where these vertices are going, here's what I'm going to suggest doing. I'm going to come over here to our graph. And what I want to do is I want to go ahead and darken in the X and Y axis just so that we know where they are. So I'm going to darken those in very quickly. Those little tiny arrows they have on there just don't seem to be enough. So we'll go ahead and darken those in. Okay. Now what you're going to do, once you've darkened those in, you're going to take your patty paper or tracing paper. I'm going to put it sort of in the corner here so that I can use this tracing paper for other problems. And I'm going to go ahead and copy on this patty paper triangle PQR. See, here's how I'm going to do it. I'm going to use red to start. I'm going to go ahead and write the vertices on here as well, P, Q, R. So I've got triangle PQR there. And again, something we noticed, vertice P is going to go to vertice S, Q goes to T, R goes to U. So what we need to do is figure out how are we going to get this thing over here on this triangle appropriately. So we're going to try to get P to S, R to U, and Q to T. Perfect. So notice they lined up right without having to flip the paper. That means we're not going to have a reflection. So that's nice. But we did turn our paper, which means we're probably going to have a rotation. So let's put this back here. So we know reflection's out because we don't have to flip the page over to get over there. So we know it's going to be between translation and a rotation. Let's try that rotation just to get it out of the way to begin with. We know that when we put it down here, we had to rotate this way. This is a counterclockwise turn, and we really only went a quarter turn. So why don't we try this? I'm going to put my pen on the origin, and I'm going to spin my patty paper and make it go 1/4 turn. So that is where triangle PQR is going to go. So it looks like we can do a rotation, and then what happens is we can actually move down and to the right, and boom. We map it from one figure to another. We mapped triangle PQR to STU. So again, let's look at that again. So we did a rotation. I'll put my pen down here and rotate. And then it looks like we can go 1 unit right, 1, 2, 3, 4, 5 units down. Let's go ahead and rotate it and draw this triangle on our paper. So Q is going to be here. That was Q. P is going to be at -4, 1. We have already studied rotation, so we should know how to do this. R is going to come here, -2, 1. So if we connect those really quickly, you can see I have beautiful straight lines. That's why I was using a index card earlier. And then we can see that this triangle is going to go to here. So let's go off to the side and write what we did. First thing we did was we rotated (90°) counterclockwise about the origin. And then we translated. Looks like we went 1 unit right and 1, 2, 3, 4, 5 units down. Now before, when we were writing compositions, or at least reading them, what happened was we wrote the second composition first. So we do this after we had our little circle there, the first composition, and then triangle PQR equals triangle STU. So we're going to come down here and write what that would look like. So again, we're going to write the second one first. So we're going to translate. 1 right would be +1. 5 down would be -5. After we rotate 90° counterclockwise about the origin. Now we did those transformations with triangle PQR to get triangle STU. Well, let's take a look at problem 2, identifying congruent figures. Which pairs of figures in the grid are congruent? I'm going to underline that word. I think that's important. Congruent, meaning we can find a sequence of rigid motions, that will map one figure to the other. So again, for each pair, write a congruent statement. That's going to mean, for example, triangle DEF is congruent to LMN, for example. So write a congruent statement and determine a sequence of rigid motions that maps one figure to the other, exclamation point. Let's do it. So what I'm going to do is I'm going to do a different color for each pair that we do, just so that you can see what I'm doing. I'm going to start with blue. I think the easiest one we see in here that we can start with, if we're going to start pairing, is probably these 2 line segments. So let's see if they're the same. I'm going to use the same patty paper I was for the first problem. I'm just going to pick a different corner this time. So let's trace PQ. I know this one seems pretty straightforward. There is a reason we are doing it with the patty paper. Okay, we notice that we can go right, looks like 2 units, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9. And look at there, they're right on top of each other, so they are congruent. What I want to point out is that we have H in G here. So we know that P is going to get mapped to H, Q is going to get mapped to G. That's going to make a difference when we are writing our congruence transformation. So let's go ahead and write that one. We can say that segment PQ is congruent. So it's an equal sign with a little squiggly on top. PQ is congruent to, we have to write this HG because P came first over here, H came first over here. So it's congruent to HG. Now, could you show that PQ is congruent to GH? Absolutely. However, we are going to say just by translation. So 2 units right, 9 units down. For that specific composition, this is the congruent statement that we need to write. So that was a translation. We went 2 units to the right, 9 units down. So we said that translation of segment PQ gave us segment HG. So that's one done. I'm going to draw a line here to separate our next pair. So let's see, let's tackle the triangles next. So let's trace this one. I'm going to use, what color am I going to use? I'll use orange this time. I'm going to go ahead and trace this one. It's D, E, F. I don't know about you, but I'm thinking probably this triangle down here. I don't know how I got that. I'm thinking it's this one. And I'm thinking we might just be able to do rotation for this one. And the nice thing about using the patty paper, we can just try it. Why not? So I'm going to put my pen at the origin. I'm just going to go ahead and rotate the patty paper. Why not? So that would be 90 degrees. We keep going, and check it out. They lay exactly on top of each other. So we know that those two triangles are congruent. So we have N here, L here, and M here. So we know that those are matching or corresponding vertices. So all we did was a rotation of 180 degrees. So I'm going to go ahead and write that triangle. What do we start with? Let's say DEF. So triangle DEF is congruent to triangle. Now, I don't want to just put the letters M, L, M, and N in any order that I want. I want to make sure that I map them correctly. Right, so first letter is D. So over here, L is the corresponding letter. So I'm going to say triangle L. E is the second letter. It looks like M corresponds with E, so M. And N corresponds with F, so N. The thing is, problems, including myself, will try to trick you. We're going to end up giving you something like DEF, and it's going to actually map to MLN, for example. You have to show that you know which vertices go together. Okay, so again, we said that that was just a rotation 180 degrees around the origin. Now notice I went this way, that's clockwise. But would it matter? Right? Counterclockwise and clockwise, 180 degrees will get us in the same place. Just side note. So we're going to write rotation 180 degrees about the origin of triangle DEF equals triangle LMN. Sorry, I was running out of the room there. And again, let's draw a line, separate those. I'm going to use green next. I like green, it's a good color. And let's see, what do we have left? We looked at this one and this one. We looked at these segments. Looks like we have these two trapezoids left. So why not start with ABCJ? It's weird lettering, but we'll take it. Let's try it. So I'm going to leave some space over the origin just in case we decide we want to rotate it. A, B, C, J. Okay. Now it looks like, see, the thing is, if we just move this, just do a translation and we move this, we've got a problem because those don't match up. They're not congruent. However, flip your tracing paper. Dun, dun, dun. They do match up. So since we had to flip the paper, that tells us we're going to have to do a reflection at some point. It's just a matter of when do we want to do that. I suggest let's just go ahead and do it right now. Let's see what happens. So we have ABCJ. What happens if we reflect across the y-axis? What if I draw a line here to represent the y-axis? So flip. So here's ABCJ. A, B, C, J. And now it looks like all we have to do is translate it one left, 1, 2, 3, 4, 5 up. One left, 5 up. So let's do that one more time. We start with ABCJ. I reflect it. I get this thing. I move it left 1, up 5, and that gives me W matches A, X matches B, Y matches C, and Z matches J. So over here we can write quadrilateral, or just ABCJ, is congruent, equal sign squiggly, to A matched W, B matched X, C matched Y, and J matched Z. Now again, this turned out really pretty, W, X, Y, Z. However, sometimes it might not. Example, ABCJ. I don't know where that came from, but whatever, we'll deal with it. So what we did was we reflected, I'm going to write this down. First thing we did was we reflected across the y-axis, which is the line x equals 0. Then we translated. We went 1 left and 5 up. Now again, the way that we've been writing this is we're going to write the second transformation, little circle, first transformation. Meaning, we do the translation after we do the reflection. So we can write, again, we're going to do this one first, the translation. So translation of 1 left, so -1, and 5 up, after a reflection across the y-axis, or x equals 0, of the figure ABCJ, gives us the figure WXYZ. So thank you for watching. I hope that was helpful with sequences of rigid motions, or compositions, and determining when two figures are congruent.